Hi, I am Ben Baker and I am a student at Idaho State University studying nuclear engineering. And I am participating in the Digilent 2012 contest in Indianapolis. Now for my project, I have developed what's called a reactivity meter. For those of you who are not familiar with nuclear reactors, reactivity is basically a quantity that is proportional to how the neutron population is changing. So in the following clip, I will go ahead and give a demonstration of the reactivity meter that I built. In order to test this, we will have to introduce a sample into the reactor, and we'll go ahead and move it back and forth to create a sine wave. And to do that, what I have right here is a tube, and inside we have a piece of cadmium. And cadmium likes to absorb neutrons very well, so we will put that in. And right now we are operating, and so over here we have Adam Malakote. He is at the controls for the reactor. And just to explain briefly why something like this is useful is because in the nuclear industry, and for us, which we deal with research reactors, a lot of our technology is very old. And so this console that we have over here was made in the 1950s. And so we still have vacuum tubes, and that's how we're operating. We're trying to transition over to newer technology, and this console right here is a product of many years, and it's still in the making per se, and it's even 20 years old because of it's reliant on senior design projects to make it. So I will go ahead and put this in, and then we'll watch the output on the screen. Okay, so what we have right here is just the motor pushing the tube, and inside of the tube is the piece of cadmium, and that is causing a fluctuation in the neutron levels because the cadmium is absorbing neutrons. Right now we are at the console, and we are moving our sample back and forth within the reactor, so it's creating a sine graph. And we can look right here on our chart recorder, and this is the only digital piece that we have that's supplemental. We have old chart recorders down here at the bottom as well going, and all the rest of this is completely analog. This piece right here is our reactivity, or our period circuit, or our reactivity measurement. Now, this isn't a very good system. It's a very simple one where it just is taking the derivative, so it doesn't have all of the complete complexity that an inverse kinetics program would have. So something like we're trying to implement in on the board, which is the inverse kinetics, would completely replace some module such as this. So we have a fairly good sine wave right now. We will go over and set up our board and see how it's doing. We have down here our Cerebot MX7CK, which is performing inverse kinetics on it. And the input is coming through here. And it's connected over in this location to a 741 operation amplifier, which is just being used to invert the signal. And we have various different sources that we could use to record the neutron population. And right now we're using a current chamber, an ion current chamber, and it's coming down to a current amplifier. We could have gone to the picoamp meter as well. Either one would have been just fine, but I liked the current amplifier better. So anyway, we're taking in the signal, and the Serabot is performing the calculations for inverse kinetics, and then our reactivity values are being displayed on this graph right here, or on this OLED screen. Now it may be hard to see on the video, but the values are right here. And the units that we use, there are several different kinds of units. The one that I'm showing right here is in cents. We use dollars and cents, and it just refers to a measurement of reactivity. And then I have a little graph showing that we have a sine wave right now. And then through the USB, the data is being sent back to the computer, where on the computer you can see that we have a nice graph. And the reactivity that we are receiving is fluctuating from about -6 cents to 3, almost 4 cents. And that's with respect to the positions that the cadmium is at.